Realizing there's nothing that y'all could do with me. All I ever ask is keep it 8 more than 92 with me 100.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now let me show you an example of calculating the pH of a salt solution. So the question asks, what is the pH of 0.15 molar ammonium chloride? And they give you the Kb, or the basicity constant, for NH3 as being 1.8 times 10 to the power of -5. So first off, let's write out the equation. NH4 plus, since I'm not including the chlorine, plus water goes to H3O plus and NH3. Since this is a salt and the ammonium ion and the chlorine ions dissociate, since that's the process of dissolving a salt, we have to write them out as equilibrium concentrations. So at equilibrium, remember when we did the ice table, back when we looked at equilibrium constants, it's the same concept. So at equilibrium, the concentration of NH4 plus is going to be 0.15 molar, which is the initial concentration, minus X. The concentration of H3O plus is going to be X, since that's how much is going to get made when that much is going to get used up of the ammonium chloride. And finally, for NH3, it's also going to be X. So in your case, if you want to draw out the ice table, that's also a very good idea. But in this case, I'm just skipping that step. So let's remember all the equations that we looked at before. The Ka multiplied by Kb is Kw, and this is 10 to the power of -14. So we can also rearrange this to get Ka is Kw over Kb. And now we have the value of Kw as 10 to the power of -14, and they gave us the value of Kb of NH3. So we can do 10 to the power of -14 over 1.8 times 10 to the power of -5, and we get the value 5.6 times 10 to the power of -10 for the acidity constant. So now let's write out the equation for Ka. And this is going to be the concentration of H3O plus, the concentration of NH3 over the ammonium ion concentration. If you want to write out what's the acid and what's the conjugate base, etc., you can also do that. So the ammonium ion in this scenario is positively charged, it's an acid, and so the conjugate base is ammonia. Okay, so then we plug in the equilibrium values that we calculated up here, and we end up with x squared over 0.15 minus x. And now we can solve for x. So the equation is going to be 5.6 times 10 to the power of -10 is x squared over 0.15 minus x. When you do the calculation yourself, you'll end up with an x value of 9.2 times 10 to the power of -6. So now, since this x is the hydronium ion concentration, we can calculate the pH, because this equals H3O plus concentration. Remember, pH is the negative log of H3O plus, which gives us the answer 5.04. So we calculated the pH of 0.15 molar ammonium chloride with this basicity constant as having a pH of 5.04. So one thing I wanted to point out was that when we calculate this x value, if x is less than 5% of the initial concentration that's given, then approximating is also valid. And so in this case, instead of subtracting negative x here, you can actually cancel out the x and just end up with x squared over 0.15. And this is called the 5% rule. So let me write that up here for you. Where basically, if this x value is going to be less than 5% of the original concentration of what we're looking for, then you can approximate it by determining that this negative x value is very insignificant in terms of the value, and so you can just cancel it out and solve it in terms of x squared over 0.15, which just makes the calculation for x a lot easier.
Unified, you better all commit suicide. Teachers ain't testing us. See, I know how I feel to be platinum plus. Niggas is jealous of you, so they try to wrap you up, tax you up.